Welcome to Chapter 9, Chemical Reactions. So Section 1 deals with reactions and equations. We'll go through the first page of your guided notes, and hopefully a lot of this will be review.
I hope.
I hope. Okay, chemical equations. This is a way of representing a chemical change. So if you add two acids together and you get a salt and water at the end, that's a chemical equation. It's a chemical change that's happening, so you need to represent it with an equation so that other chemists can come by and recreate it.
Okay.
This chemical equations, they consist of reactants and products. You should have heard of those terms before. Reactants are to the left of the arrow, so they are the things that are doing the reacting, and then the products are to the right, so this is what is produced. The arrow there, I wrote another arrow to it that says yields or produces. You can have a lot of different verbs there, like decomposes to, or and there's lots of things, but most of the time it means yields or produces. Okay, so identify the reactants and the products of this. Which ones are the reactants, Mrs. Tom?
Well, if it's on the left side of the arrow, we're going to have NaCl, which is sodium chloride, and HBr, which is hydrobromic acid.
Yes.
But they don't know that yet. Yes, they do.
They know how to name it. They know how to name acids. Yes, you do. Okay, and then the next, the products would be hydrochloric and sodium bromide. So if you want to circle these on your notes, better make sure you know how to identify reactants and products.
Yeah, we're going to have problems if you don't know that.
Okay, now we get into balancing. According to the law of conservation of mass, we must have the same number of atoms at the beginning of a chemical reaction as we do at the end of the chemical reaction. So if you start with 2 carbons, at the end you better have 2 carbons.
Okay.
That's just the law of conservation of mass. So we must balance the equations to obey this law.
Balancing, we're going to be using...
Well, okay, once the reactants and products have been written, we use large numbers called coefficients to balance the atoms. So coefficients, the big numbers on the front, all it does is tell you how many of each compound or molecule we've got.
Okay.
So down here on the bottom, it has a big 2 in front of H2. So it tells you we have 2 molecules of hydrogen gas.
Why is it molecule?
Because it's hydrogen, covalently bonded with hydrogen.
Okay. So that's why we're going to know the difference between the atom and the molecule and the compound.
Mm-hmm.
So the molecule is going to be covalently bonded, which is all of those in that equation we have right there.
Yeah.
Atoms are going to be any single atom, such as a metal, iron, copper,
Sodium,
magnesium, potassium, any of those. And then your compounds are anything ionically bonded. So this is bringing in big time chapter 7 and 8 all together.
So like NaCl, I don't know, that's the top one that came off my head.
Yeah, so NaCl is a compound. If it was just sodium, then it would be just an atom. And if it's covalently bonded, you're going to have the molecule. So you've got to be able to identify if something's an atom, a molecule, or a compound by now.
Yes.
It'll be big.
Okay, coefficients tell us the number of atoms in molecules and compounds. So example 2, CO2. It has 2 atoms of carbon and 4 atoms of oxygen. So you should be able to, this will come into calculations that we have to do later. So make sure you know how to do this now. It'll make your life easier when we get into the really tough chapters in a couple weeks. So practice down here. It's on your notes too. But we have 3 calcium in parentheses, MnO4 parentheses 2. What's the name of that molecule? Or no, it's ionic, so it's a compound.
Yes. Well, what are we going to do? We're going to take our 3, and we've got to multiply it through, right? So the 3 is going to multiply through the Ca, through the Mn.
Oh, no.
Oh, go back, go back.
What is going on? Okay, pointer options.
Okay.
Thank you. Okay, anyways.
All right, so with our calcium permanganate, we're going to multiply that 3 through the calcium. It's going to go and factor through the Mn, and it's going to factor through the O. But we also have that little 2 on the outside of the permanganate part. So we've got to make sure, we've got to make sure that that 2 goes through as well. So really, how many carbons we're going to, calcium, we're going to have 3 calcium because of the coefficient multiplied by the 1 calcium that was there.
There's nothing there.
And then the MN, originally the MN would have had 2 MNs due to the parentheses and the 2 outside. And now there's 3 in front, so we're going to have 6.
Okay, so 2 times 3 gives us 6.
And now we're going to have the oxygen started off with 4, with the 2 outside, means we multiply those 2 together, which is 8.
Mm-hmm.
And then we take the 8 and multiply it by 3 for our basic math skills of 24.
Good. You need to make sure you know how to calculate how many of each atom there are.
Okay, so we got a little factoring going on.
Okay, guidelines for balancing. So in case you've forgotten how to balance, we're going to go over these. Start with an element that is unbalanced and see where it takes you. So this is like the most general rule you could have, because you just start with anything and see where it goes. So if we started with sodium, check it out. We've got 1 sodium here and we've only got 1 here.
That's good.
So those are actually balanced. So now let's go to Br. Br, there's 1 over here. How many over here?
2.
Okay, so we need to write a large 2 out front. That is our coefficient. Now we've got 2 sodiums and 2 bromines. So bromine's happy over here, but now we need to have a 2 right here.
Okay.
Okay, now we've got 2 sodiums. That makes this side happy. 2 chlorines, 2 chlorines. We are balanced.
All right. So fixing just a few little places ends up fixing everybody else.
Mm-hmm.
So we got to just make sure as we read through, start with one element, find it on the other side, and then just go through. The next rule, though, says start with our polyatomics. Oh, you picking another bright color.
Changing the color.
There
Yes.
you go. Polyatomic ions on your cheat sheet. You should remember these from chapter 7. Start with those. Look for the parentheses. If the parentheses on one side and there's nothing on the other side, start with those big chunks. Now you've got to leave them as one big unit, one big chunk. So in this first equation, we've got this acetate as C2H3O2.
Yep, right here.
Now that says that there's 3 there. So I'm going to go and look on the product side. And there's only one of them because there's no other parentheses. So we've got to make that balance. We're going to put a big 3 in front of that whole thing.
It's good to do these in pencil.
Yeah, there, yes.
Because you'll go back and forth in a lot of these.
Right. The next thing says let's do the Na. Since we just changed that 3, let's keep with that. Follow it to the other side. There's only 1. So now there's 3 there. Then we're going to go to the aluminum. We're not to the rule yet, but we always save H's and O's for last.
Okay, yep.
Now we're going to go to aluminum. Aluminum is good.
We've got 1 and 1.
Okay, so the next thing we got to check is just our H's and O's. We've got 3 H's and 3 O's on the left, and we've got 3 H's and 3 O's on the right due to our parentheses with our hydroxide.
Okay, so because it's a hydroxide over here and a hydroxide over here, you can treat it as one unit. But sometimes your polyatomics, the second part, if it's broken up, you'll need to balance the elements individually. So sometimes you'll have a hydroxide on one side and then you'll have water on the other. So then you need to actually just do them individually.
Yeah.
Okay. Don't forget about your diatomic elements. So if you were writing a formula, okay, and you're saying that you have chlorine gas. Chlorine gas is Cl2. These are on your cheat sheet. So make sure that you remember your diatomic molecules so that you have your formulas correct. Because one of the biggest things is if you don't have your formula correct, you're never going to be able to balance and you just run around in circles. Okay, so this is the little upside down L on our periodic table. So these are going to be your diatomics and hydrogen. Again, they're listed on your cheat sheet.
Why are we so nice?
I don't know. Okay, hydrogen and oxygen, save those for last only because they are bonded to so many different things that
They get complicated.
they're
and
all
annoying,
over the place.
And you're going to cry if you start with those. You really will.
Okay, if there's an odd number of one element, make it even. Okay, so this one's a doozy, but we'll get through it. All right, so what do we do first?
So we're going to start with carbon.
Okay,
So we got
carbon, there's 2.
And we put a 2 there.
Okay.
All right. Now we go to hydrogen and oxygen. Do hydrogen first, leave oxygen for last.
Okay.
So I got 6 hydrogens and then 2. So 2 times what is equal to 6 is the 3 that Mrs. Kelly is trying to write.
There we go.
So 3 times 2 equals the 6 H's. So our H's are good. But now the O's.
Yes.
We've got 2, so we
Uh-huh.
can always multiply 2 by something, but it will always give us an even number. But on our product side, we've got
2 here.
but there's a 2 in front, so that makes 4.
Uh-huh.
With the other 3, that's going to give us a 7.
Right.
We can't multiply something by 2 and get to 7.
Nope.
It's no good. So our
Because your
first
coefficients, I forgot to say this, coefficients always have to be whole numbers, no decimals.
no 2.5. So what we have to do here, our first try, it didn't work.
Right.
So we're going to go.
So I don't know how to erase it, but we're
We'll-
just gonna
all right,
scratch
scribble
it out.
or write. We'll just write above it.
Scratch it out.
So our next hint to you, if that didn't work,
Try
and
again.
you got left to the O's, double the carbon number. So instead of just leaving it as a 1, go to a 2. So
Mhm.
we're going to go to 4
Okay.
carbons. So we're going to multiply the first
So
one
we're
by
gonna put
2.
that 2.
We're going to go to 4 on the product side. That makes us 12 hydrogens on the left. So I need a 6 on the right.
Okay.
Now we got to add. Don't forget to add up everything on both sides. So we
Okay.
got oxygens that are split on our product side.
Yes.
So 4 times 2
8.
is 8 plus 6
Mm-hmm.
is
14.
a lot. So if we've got 14 oxygens, what times 2 equals 14?
7.
So our final one here is 2, 7, 4, 6. Yay!
Yay.
You are going to get a lot of practice on these balancing because it is going to be a huge portion of every chapter from here on out. If you have any questions whatsoever, please ask us when you're doing the practice. Make sure that you can visually see it. Mrs. Kelly and I might give you some other hints of using fingers to try to find each
Right.
element on each side. There's other ways you could do it by using charts and add
Yeah.
up each thing.
You can
So-
make a T-chart.
We're going to try to find the best method for you that you can do these quickly and easily and without any crying.
But really, practice is the best way. And I'm going to see if there's another slide or not. Yes. Okay. If you tried to balance it 3 times, don't waste your time trying to do it again. Go back, check your formulas. If your formulas say you've got a diatomic and you only left it as a Cl, you need to go back through and make that a 2. That probably will save it
Yeah.
altogether. Or maybe you forgot that magnesium was a 2+ and you counted it as a 1+, and now your whole formula is wrong. Go back and check those, because if those are incorrect, you will never be able to balance.
Right.
And then the other thing, reduce your coefficients to the lowest possible ratio. If they're all even, go back through and divide them all by 2
Yep.
until you get at least a 1 in there. So
And
you
we-
can't reduce it anymore.
And we don't write ones.
Nope.
We leave things blank in front because as soon as it's written, it's understood that it's a 1. We don't write ones.
Yes. We do that a lot in chemistry.
Other things for mistakes that we normally see when you're making your reactants into products, not all subscripts will transfer over. You've got to make sure
Right.
that you are checking charges and making everything brand new each time you're making a product. That way you've made it properly and then you fix the subscripts by using those coefficients.
Good.
Yay, section 1, done.
That's balancing.